Find the nth order Taylor polynomials of the given function centered towards 0, 1, 2. It's the same process. Shall we do this one just to get some experience with natural log? That'd be good? Let's do this just to get experience with natural log. By the way, you see the P0 of x? That would be just this one. P1 of x is this one and this one together. But P0 would be only the constant term. Right? It's like there's an x to the 0 power here. That's what it's like. Up here. F of x equals ln. So we're going to do the 0, 1, and 2. We are centered at 0. So here we go, make our list. Copy the original function. And then we're going to find f of the center, 0. Simply substitute 0 for x. So that will give us natural log of 1, and natural log of 1 is 0. So P of 0 is just going to be 0 when we get there. First derivative. The derivative of natural log x is 1 over x, but we have more in here than just x, so we're going to have to apply the chain rule. It's going to be 1 over this argument times the derivative of that. The derivative of that inside will be? Negative 10. So this is negative 10 over 1 minus 10x. F prime of 0. So if we put in 0 for x, we'll get just 1 on the bottom, right? And negative 10 divided by 1 is negative 10. There you go. Second derivative. So we can either use the quotient rule here, or we can modify it and use the product rule. Which way would you like to go? Quotient, okay. So quotient is, did you guys learn the Lodi high minus high low all over the square of what's below? You ever heard it like that? So when we do derivatives with the quotient, we do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and it's over the denominator squared. So low d high, d is derivative. Low d high, low times the derivative of the top, low d high minus high d low over the square of what's below. I don't know if it's still posted, but do you guys know Mr. Tayar here at the college, one other math teacher? Well, years ago, this was like way before COVID, one of his students made a song about it and posted it on YouTube. So there's a low D high minus high D low over the square of what's below song on YouTube about it. Maybe I'll look it up. So it's almost embarrassing to watch, but here we go. Quotient rule. bottom times the derivative of the top. So it'll be 1 minus 10x times the derivative of the top is 0. That's low-D high. Minus the top times the derivative of the bottom. So minus negative 10 times the derivative of the bottom will be negative 10. That's high D low. Over low squared. 1 minus 10x squared. Low D high minus high D low all over the square of what's below. See it now? All right, so 0 times that's going to be 0. We have 3 negatives there, so it's going to be negative 100 over this denominator. That's good enough. So if we evaluate that at 0, 10 times 0 would be 0, 1 squared is 1, it's just going to equal negative 100. So here we go. P sub 0 of x, that's this term, which is simply this. So P0 of x equals 0. P1 of x, that'll be this term plus this term. So it'll be 0, which I'm not going to bother to write, plus put negative 10 in for that derivative. Negative 10 times, I don't even need a parenthesis. Negative 10x, because it would be x minus 0, so that's just x. Negative 10, x minus 0. And P2 will be this term plus the quadratic, which we got negative 100. So this would be negative 100 over 2, which would be negative 50 x squared. All right, let's put this in. We'll look at this one in decimals, see what it does. So P0 of x for this problem was 0. P1 of x is negative 10x. I won't bother to copy and paste it, that's easy. And P2 is negative 10x minus 50x squared. Oh, I want you to do this part. See up here? 11.1.25 T. That T is for technology. So they want you to do what we've been doing on Desmos, to graph it and match it up. You don't have to graph these by hand. You're welcome to use Desmos. Okay? So let's go ahead and put it on Desmos. Here are all these. Our original function is ln 1 minus 10x. P1 of x is 0. Let's go over here so we can see it. That doesn't look good.
Oh, negative 10x.
See what happens here, negative 10x. That's better.
Yeah, that's not good.
So I guess 0 is just a real bad approximation. And then we can copy and paste this here too. You'll copy the whole thing, paste it, and change the 2 to a 3 down there. And then add, which actually minus 50x So the black is the natural log graph that we're approximating. And you can see that the blue one here follows it. Is a reasonable approximation for more duration here, further to the left. And to the right too. So got that picture in your head? Take a mental snapshot there. Go click, do your little digital picture. So it's stored in your brain with a whole bunch of ones and zeros. Yeah. Is it that one? No. Is it this one? That's a maybe, isn't it?
Possibly.
Here's your natural log. See it has f of x there? P1 of x is this. P0 of x is the x-axis, just like we had. So that's a likely. Let's just see what this one looks like. I don't think our line went through it like that, did it?
No, I don't remember that. Oh,
So on something like this, you are welcome to use decimals. All right? Okay. Any questions? What do you think we're done? Yeah, we'll call it quits now.
yeah.
Well, we'll do maybe a few more examples out of this on Wednesday. I don't want to push it too hard before the exam on Friday. You see how many questions you have on Wednesday. Have a great day. We'll see you guys on